Welcome to today's Explainer. We're jumping right into the absolute cutting edge of 2026 to see exactly how four massive technological rivers are crashing together to build our future. We're looking at a profound transformation where predictive analytics, generative AI, game theory, and edge computing are no longer operating in silos. They're converging, and they are doing it incredibly fast. So if you want to understand how the future of business, technology, and even human interaction is being rewritten right this very second, you are in exactly the right place. Let's kick things off by challenging how we actually think about forecasting. For decades, predicting the future has been this ultimate high-stakes game in business, right? But the future is no longer just about guessing what happens next based on a giant spreadsheet of numbers. It's about simulating and actively engineering it. We're moving from a world where algorithms were simply analytical eyes to one where they act as an executive brain, literally drafting the script for how you should dominate that future. To wrap our heads around this massive shift into the future, we're going to follow a quick 6-step roadmap today. We'll hit predicting the future, generative and predictive convergence, game theory meets AI, the shift to edge, the rise of autonomous agents, and finally, humans and AI co-evolving. Let's get right into it. Section 1. Predicting the future. We're moving from classical statistics to dynamic AI models. To really appreciate where we are in 2026, we have to look at the baseline. Predictive analytics is a market that's just absolutely exploding right now. I mean, it's on a trajectory to blow past $78 billion by 2032. While the old-school models relied heavily on rigid statistics and manual feature engineering, modern predictive AI learns completely autonomously. It ingests massive, high-dimensional datasets to capture these really complex, hidden, non-linear patterns. This is exactly what allows modern enterprises to anticipate financial anomalies, optimize resource allocation, and proactively shut down supply chain risks before they even materialize. But on its own, it definitely has a glaring limitation.
Moving right along to Section 2, Generative and Predictive Convergence. This is the new standard for decision-making.
Now, predictive AI is incredibly accurate, for sure, but it has always suffered from this infamous black box problem. Traditional models pumped out highly accurate raw numbers, but they were super hard to trust because those complex neural layers rarely bothered to explain their reasoning. It required a human to basically manually walk the path to figure out the why. Well, generative enhanced AI completely changes the fundamental chemistry of this data. It translates those complex mathematical weights into plain language executive summaries. It doesn't just toss a percentage at you, it explains exactly why that prediction was made in the first place. Picture this. Your predictive engine flags a 5% demand spike for a product. Back in the day, you'd get that number and basically be left on your own to figure out the rest. But now, the generative layer steps in and runs simulations on thousands of dynamic, multivariable disruptions, like global port congestion or even a sudden heat wave. It then whips up a plain language action plan telling you exactly how to adjust your inventory and procurement cycles. It acts as an interface that explains forecasts with reasoned context, perfectly bridging that gap between data science and actual executive action. But what happens when the variables you're trying to predict are, well, unpredictable humans? That brings us to Section 3, Game Theory Meets AI, Modeling Strategic Human Interactions. Let's be real. Humans are highly competitive and totally unpredictable. So if you want to forecast the future of any market, you've got to model strategic human interaction. Enter algorithmic game theory. Historically, training AI to understand strategy meant tweaking millions of opaque parameters in a deep neural network. Instead of updating raw, opaque numbers, which, let's face it, is way too risky for high-stakes settings, researchers are doing something wild. They're prompting large language models to generate strategies directly as executable, human-readable source code. By operating in the space of discrete programs, the AI can synthesize clear, rule-based strategies that are easily verifiable and actually safe to deploy in multi-agent environments.
When you actually map expected payments against the probability of winning in financial markets, you really start to see the mathematical realities of market behavior. By applying game theory here, algorithms can now model our psychological biases, market inefficiencies, and the strategic bid shading of human investors. This allows AI to move way beyond just recognizing historical data patterns to actually understanding the competitive dynamics and equilibrium outcomes of the market. The algorithm isn't just looking at a stock's past anymore, it's anticipating exactly how human agents will strategically react to future economic shifts.
All right, Section 4, the shift to edge. We are moving compute completely out of the centralized cloud.
$80 billion. That is the projected size of the global edge AI chips market by 2036. What we're witnessing here is a massive structural architectural shift. The computing landscape is actively transitioning from centralized, monolithic cloud environments straight to distributed, localized hardware. And why is that? Because the future demands low latency, low bandwidth consumption, and localized data privacy that the cloud simply cannot provide when milliseconds matter. And this distributed hardware? It is not science fiction. It is being deployed right now across some massive domains. We're talking level 3 self-driving cars, making split-second safety decisions without ever talking to a cloud server. It means humanoid robots navigating dynamic automotive manufacturing floors on their own. It means AI PCs processing huge operations locally and factory sensors predicting their own failures before a machine actually breaks down.
To make all this localized intelligence actually work, the tech industry is pulling a massive pivot. Sure, the giant large language models grab all the flashy headlines, but the real operational revolution for the future is in micro LLMs or small language models. These are highly efficient, compact, task-specific models optimized to live directly on your edge devices. They require drastically less power and compute, which ensures total privacy and near-zero latency, all while still delivering incredible AI capabilities right where the data is actually generated.
Which leads us perfectly into Section 5, the rise of autonomous agents. We're evolving from passive tools to active systems. We are in the middle of a fundamental shift in how we interact with software. We're completely moving away from passive tools that require us to constantly click, prompt, and supervise. Instead, we're entering the era of agentic AI. These are autonomous, often edge-resonant agents that actively manage dynamic environments. They don't just tell you what might happen. They take closed-loop actions to inspect, adjust, and remediate systems in near real time.
Let's walk through how an agentic workflow transforms a modern supply chain crisis from end to end. First, the predictive model triggers an alert for an impending stockout on a key component. But instead of just blinking red on a dashboard, the AI agent proactively contacts your alternate suppliers. It then negotiates terms based on your preset business parameters. And finally, it presents a fully drafted, finalized contract for approval. The human is left, thankfully, to simply provide the final sign-off. And just to make sure the AI isn't going rogue, predictive guardrails constantly cross-reference the agent's actions against the original data to absolutely prevent hallucinations. It's just a completely transformed workflow.
And finally, Section 6, humans and AI co-evolving, the systemic feedback loop. When these autonomous, highly strategic edge agents start interacting with the human population at scale, they don't just sit back and observe our behavior, they actively shape it. Think about it for a second. If an algorithm gives you highly accurate stock predictions, you're going to change your trading behavior. If an autonomous vehicle enters traffic, human drivers naturally adapt how they drive around it. This creates a massive feedback loop. Researchers call this framework evolutionary prediction games. We're entering a phase where the machine and the user population are no longer separate entities. They are dynamically co-evolving, locked in this natural selection process of adaptation and reaction. Artificial intelligence has fundamentally graduated. It is no longer just a static observer sitting in a cold, distant cloud server waiting around to recognize a pattern. Thanks to the convergence of generative capabilities, game-theoretic strategy, and ultra-fast edge computing, AI is now a highly strategic participant acting in real time within our physical and economic ecosystems. It literally marks a structural shift from passive pattern recognition to active strategic coevolution.
This is a profound structural shift that totally redefines the future of business, technology, and honestly, our daily lives. The wall between simply knowing what's going to happen and actively doing something about it, that wall has crumbled. We are left with a massive new landscape to navigate, leaving us all to figure out exactly how we'll adapt, compete, and thrive as we co-evolve alongside these intelligent systems. So, the big question remains, what role will you play in this co-evolving ecosystem? Thanks so much for joining me to explore the future today. I'll see you next time.